Now that we've looked at how to find the correlation coefficient in Excel, we're going to look at some of the properties of the correlation coefficient. So some of these you already know, like this first one. Correlation is between two quantitative variables. So if those variables aren't quantitative, you can't use any of these processes. Okay, you have to do something different. The next one here is correlation has no units. So we looked at the formula earlier, and while you don't have to calculate it by hand, one of the things we talked about was that process of the way the formula works standardizes the numbers so they take out the units so we can compare them really nicely. So there should never be any units on your correlation coefficient. The correlation coefficient does not change when we change the units. Okay, so because we took those units out, it doesn't matter if we're measuring in feet per second, miles per hour, we're still going to get the same correlation coefficient. Changing the order of the variables does not change the value of R. So you might have caught on to that when I was showing you the correlation coefficient in R, that I switched up which order I highlighted them in. And in terms of the correlation coefficient, it doesn't matter at all. So there's no difference whether you highlight A and then B or B and then A. The correlation coefficient is between -1 and +1. So if somebody told you they got a correlation coefficient of 8.72, there's definitely something wrong with that. And then the last two are more just kind of details as opposed to properties. So the sign of R tells the direction. So if R is positive, it's uphill. If it's negative, it's downhill. And the correlation is really sensitive to outliers, or another way of saying that is it's not resistant to outliers. So removing them or adding them in can really change the value of the correlation coefficient. And that's because we use the mean and the standard deviation to calculate this, which means that then because those aren't resistant to outliers, then this also wouldn't be. All right, so we're going to try these first 5 properties out. So if you look at your notes, you'll see you have 5 sentences. You need to figure out which property each sentence breaks. So each one has something wrong with it related to that list we just looked at. So go ahead and pause the video and see if you can figure that out, and then we'll come back and go through them. All right, so hopefully you gave those a try. This first one, the correlation between Olympic gold medal times for the 800-meter hurdles and the year of competition is R equals -0.66 seconds per year. So the problem with this one is that it shouldn't have units on it. It should just be the correlation is R equals -0.66 and that's it. So the units on there is a problem. The second one, the correlation between Olympic gold medal times for the 100-meter dash and the year of competition is R equals 1.37. So that one breaks rule number 5 because it is bigger than +1. Number 3, since the correlation between Olympic gold medal times for the 800-meter hurdles and the 100-meter dash is R equals -0.41, the correlation between the times for the 100-meter dash and the 800-meter hurdles is going to be the positive version of that. So this one, all they've done is switch the order that they highlighted these variables in, and that's where the problem is. That correlation coefficient isn't going to change. So either both of them are -0.41 or both of them are +0.41, but they can't be different if you're using the same variables. If we were to measure Olympic gold medal times for the 800-meter hurdles in minutes instead of seconds, then we would need to take that correlation coefficient and divide it by 60, which gives us -0.011. Right, so this one, that problem is you don't need to do anything. We've stripped the units out in this process of making the correlation coefficient, so it's going to stay the same whether it's measured in minutes or seconds. All right, and then the last one, after conducting a survey at a pet store to see what impact having a pet had on the condition of the yard, the news reporter stated there appears to be a strong correlation between owning a pet and the condition of the yard. This one breaks the very first rule. Neither of these are quantitative. Owning a pet is a yes/no question. And then the condition of the yard, I'm going to guess they're going to do like poor, fair, good, great, fantastic, those kinds of things. So neither of those would be quantitative variables. right, so you will see these properties on the homework and the quiz. And so hopefully this gives you a good sense of how to know what's going on with those statements.